Well, we're ready to move on to the second part of 6.2. Remember that on the assignment and on last time's notes, we looked at a problem like this and we went through and talked about how we can use words and numbers and graphs and tables to represent some equivalent ratios, very similar to equivalent fractions and that sort of thing. So hopefully you've got that practice all figured out. And let's take a look at this next part. Very similar. We're going to throw in some different words and some different types of instructions here. So as we go through and do this, see if you can catch the differences here. We're actually going to be doing a couple of problems from your assignment. So if you'll follow along with this, you'll actually be in really good shape to work on today's assignment. So again, the I can statement for this section is I can understand and use equivalent ratios. So we're talking about those ratios that are equal to each other. And I want to point out this word. When quantities are proportional, they have the same corresponding size relative to one another. So as one gets big, the other one gets big. As one gets small, the other one gets small. And they do that so that they're relatively the same size. And that's kind of a complicated concept to figure out, but we're going to work more on this. But we are going to use the word proportional. But we're going to kind of summarize this by saying, well, if they're the same size corresponding to each other, we could reduce them and they would make equivalent ratios. Equivalent ratios. Okay, so on problem number 5 it says 3 cups of sugar are required for 2 batches of cookies. And then we go through and we're going to do this problem, very similar to what we did yesterday, but I want you to pay attention to a couple of things. First of all, we're going to set up this ratio and we're going to fill out this table using equivalent ratios. You'll notice that the number of batches is already determined for us and we have to figure out the number of cups of sugar. And that's kind of a standard way of writing something like this. Even though the sugar came first in the problem and the number of batches came second, when we set up a problem like this, we kind of want to figure out, well, you wouldn't figure out how much sugar you need and then figure out how many batches you're going to do. Normally we'd say, okay, we want to make this many batches. How many cups of sugar is that going to require? So let's go ahead and write down the 3 cups that are required for the 2 batches. Well, if we went to 3 batches, let's think about that for just a second. That's not really an even number, but we can fill out another one that would be an even number like we did on yesterday's assignment. So if we started off with 2 batches and that required 6 cups of sugar, what if we did 4 batches? Well, that would just be a double batch, so we would double the amount of sugar, so this is going to be 6. And if we did that again, so for every 2 batches, 3 cups are required, 4 batches would be 6 cups of sugar, and 6 batches would be, well, that would be another 3 cups of sugar, so that's going to be 9 cups of sugar altogether. And hopefully you can see that each one of those would reduce to that same equivalent ratio of 2/3 if we wanted to think of it that way, or 3/2 if we were going to do the sugar on the top and the batches on the bottom. Now let's come back and let's see if we can fill this number in. Well, if this is 2 and this is 3 and this is 4, 3 is right in the middle of 2 and 4. So that means that this one right here, if we're going to make these proportional, if we're going to make these have the same relative size to each other, this one's got to be right in the middle of 3 and 6. So stop and think about that. What would be right in the middle? In other words, kind of what would be the average between the two of those? Well, it would be 4.5 cups. And for 5 batches, it would have to be right in between here. So what's right in between 6 cups and 9 cups? It's not quite 7, that's a little close to 6, and it's not quite 8, that's a little too close to 9. So this is going to be 7.5 cups. So what I'd like you to take a look at right now is that we're counting up by, we're adding one more batch, one more batch, one more batch, one more batch. What we're adding here is another 1.5 cups of sugar, another 1.5 cups of sugar, another 1.5 cups of sugar, and another 1.5 cups of sugar. So we're going to take a look at this in kind of a graphic way. We're going to draw a picture of this like we did on the other one. So graph as many ratios as will fit on the graph. Draw a line that passes through all the graphed points and extends to the edges of the graph, and be sure to label the axes. So to make this fit, I'm going to draw this, I'm going to draw this a little bit smaller, shrink this down in size just a tad, and let's see what we've got here. Okay. So let's do the top one. We normally do the first one as the x's and the second one as the y's. So we're going to do the x over here. We're going to do the batches right here. So this is batches over here. And this is going to be cups of sugar. Okay, so we're going to do cups right here. and we're going to do 2 batches is 3 cups of sugar. So 2 batches, 3 cups of sugar, so we're right there. 3 batches is 4.5 cups of sugar, so 4.5 cups of sugar. 1, 2, 3, 4. This would be 5 cups, so 4.5 would be right in the middle. And if this works out to be a line, it's going to be something kind of like that, but let's check these other points and make sure. 4, 6, so 4 batches. 1, 2, 3, 4, 5, 6. Notice how we're lining up there. 5 batches is 7.5 cups of sugar, so there's 6, 7.5 would be right there. And then 6 batches would be 9 cups of sugar. So 6 is right here. We've got 3 cups, 6 cups, 9 cups is going to be right there. And then remember, it says extend the graph, that straight line. I'm going to take advantage of a tool that I've got on here, this little line tool. So what I'm going to do is if I draw a straight line, I'm going to start right here, and then I'm going to draw a straight line that goes like that. So it kind of hits all of those points. It says on part C, choose a point and explain what it means in this situation. So you could pick any one of these points on here. Let's choose this one right here. So this one right here is 5. That's the horizontal point and the horizontal coordinate, and the vertical coordinate is 7.5, so 7.5. So we're going to choose 5, 7.5. And it says explain what it means. Well, remember, these are batches on the horizontal axis and cups on the vertical axis. So this would be 5 batches. Needs, let's see, 7.5, so 7.5 cups of sugar. Okay, so any one of these would be fine. So if you pick this one right here, this would be 4, 6, so that would be 4 batches, requires 6. So it's kind of just repeating what we had over there. And then it says draw a right triangle to represent how you would move between any 2 points you graphed. Any 2 points from the table will do, and remember, move vertically then horizontally, so similar to what we did yesterday. So to make this a little bit more clear, I'm going to use different colors here. So I'm going to go from this one. This is what I call a convenient point, and this is not a very convenient point because this is in the middle of 2 points. It doesn't cross at one of those nice dots that has like integer coordinates. So we're going to go from here to here. So we're going to go from beginning to end. So we need to go vertically up until we match that one, and then we need to go horizontally like that. So let's check and see what we've got here. This is up 1, 2, 3, 4, 5, 6. So that would be up 6 and over 1, 2, 3, 4. Okay, so we're going up 6 and then we're going over 4. And it says use the triangle to determine the constant of proportionality. So what I'd like you to notice is that no matter what points we picked on here, like let's say that we picked these 2 right here. So let's say we went from here up to here, and we were to figure out how far we went up. Well, we went up, that would be 1, 2, 3, so that would be up 3, and that would be over 1, 2. Okay, so you could use any of these, and here's the cool thing that happens. We're going to put the vertical movement on the top and the horizontal movement on the bottom. So I'm going to take the vertical movement, which is 6, and the horizontal movement, which is 4. And for the green one, I could take the vertical movement, which is 3, and the horizontal movement, which is 2, and you'll notice that those are both equivalent ratios. I could actually reduce 6/4 and turn it into 3/2. Okay, so it says the constant of proportionality is the number we multiply the horizontal coordinate by to get the vertical coordinate. It's the same as the reduced equivalent ratio. Okay, so we're going to cover more about what we're talking about right here a little bit later, but you'll notice that if we reduce this this ratio of the vertical over the horizontal, we get the same thing either way. So the answer on this problem is 3/2. Okay, this is what we call the constant of proportionality. Okay, and it says how many cups of sugar are needed for 1 batch of cookies. Well, if we were to look on this over here, let's look at our graph. So this would be 1 batch of cookies. Well, let's go up for 1 batch and let's see where we end up. We end up right there. And if this is cups of sugar, this would be 1 cup and this would be 2 cups. Well, we've got to be right in between. So that would be 1.5 or 1.5 1.5 cups of sugar. Or, if you stop and think about it, if we were to write that as a ratio, as a single fraction, 1 times 2 is 2, plus 1 would be 3/2. Turns out to be the same. Now, we don't need to make a big deal of that. All you need to do right now is just answer each one of these questions. As long as you can answer each one, we're going to have plenty of time to kind of put these pieces together over time. But this is one way where we can represent them numerically and organize them in a table, and then look at a picture of what this looks like and kind of see, okay, what relationships can we find here? And one thing that we can find here is what's called the constant of proportionality. And if we do this little triangle figure on each one of these, we can find out what that constant of proportionality is. And it happens to be the same as each one of those reduced fractions. Okay, so let's take a look at the next one. Same type of instructions, and again, these are just like the ones on your assignment. So it says in Alaska there are 5 men for every 4 women. So 5 men for every 4 women, and we're going to complete the table. So that would be 5 men, 4 women. Let's see, this would be 10 men. So that would be, if that went up by 5 more men, that means 4 more women, so that would be 8. So if we do 5 more men, this would be 4 more women, so that would be 12. So you'll notice what we have here is we're counting up by 5 on this one, and we're counting up by 4 on this one. So this next one's going to be 16, and this next one's going to be another 4, would be 20. And it says, what does 0, 0 mean in this situation? But remember, we've got to graph this first. So let's go through and graph these. So again, we're going to do the first one like X and the second one like Y. So this is going to be men over here, and this is going to be women over here. So 5 men, 4 women, we're right there. 10 men, 8 women. 10 men, 8 women, 8 would be right there. So it looks like that. 15 men, 12 women, 15 men and 12 women, so that would be right. Let's see if we got that. Oops. And then 10 men and 8 women, so 10 men and 8 women, 8 would be right there, so we're going to go right there. 15 men and 12 women, 15 men and 12 women, we'll follow that straight up. 12 would be right there. And what's a little bit comforting is it looks like things are lining up so far, and then we get 20 and 16. So 20 is right at the end of the chart here, and then 16 would be right there. Okay, I'm going to do the same thing I did before. I'm going to line these up, and I'm going to draw a line. So I'm going to line up right here because that looks like it lines up with all those points. So I'm going to start right there, and I'm going to stretch that so that it goes through each one of those points. That looks pretty good right there. Go ahead and set that line in place. Let's see, so it's passed through all of those, extends to the edges, we've labeled the axes and all that sort of stuff, and it says, what does the point 0, 0 mean? Well, that would be this point right here, and that would be 0 on the horizontal axis, so that would be 0 men and 0 women. Okay. If the x-coordinate represents the men and the y-coordinate represents women, if we've got 0, 0, that means there's nobody there. Okay, and then it says draw a right triangle to represent, and remember that's got a right angle in it, how you'd move from 5, 4 to another point on the graph. So I'm going to move from 5, 4 from this one right here to another point right there. So I'm going to go up this far, and then I'm going to go over this far. And I'm going to put that little mark in there. That little square means that's a right angle. And so we would go up 1, 2, 3, 4, up 4, and over 1, 2, 3, 4, 5. So that would be 5. Let me do another one here. Let me do this one. So this would be up this far, and that's even with that, and then over to there. So that would be up 8 and over 2, 4, 6, 8, 10, over 10. So we've drawn that, and then it says use that triangle to determine the constant of proportionality. So remember, what we're going to do here is we're going to put the vertical, which is the up and down part, so that's going to be 4, over the horizontal, which is 5. And on the other one, we're going to do the vertical, which is 8, over the horizontal, which is 5, and, or sorry, the horizontal, which is 10. And you'll notice that those are equivalent fractions. So that is, if we put it in reduced form, that is the constant of proportionality. So this is going to be 4 over 5, 4/5, okay? And then it says, how many women are there for each man? Now, this gets to be kind of an interesting question. But if you think about that last one, here's what we did on that last one when we were trying to figure that out. It said, how much sugar, how many cups of sugar are required for one batch. So we went to one batch and we went up here and well, we got 1.5. We'll take a look at this. One man would be right there, and it says how many women are there for each man. So this would be right here. That would be one man, and we're a little bit less. Well, if you had to take a guess at what that is, I mean, it's half would be right here and one would be right there. So it's somewhere in between those. So if you take a look at this, what I'd like you to take a guess at, because up here 3/2, the constant of proportionality, was the same as 1.5 that we could kind of see on this one. Well, let's take a guess at what this would be. If we did 4/5, first of all, they would be the same, and then if we did a decimal, that would be 0.8. Hopefully we're still familiar with those common rational numbers. See how those come up again? What that means is 0.8 women for each one man. Now, that seems like a dumb thing to ask, because, I mean, you can't have 0.8 of a woman. But if we were to do something like this, how many women would there be for 100 men? Well, let's see. If men were the denominator, if that was 100, and the numerator for this one was 4, and that was a 5, well, let's see. We would times by 20 to get this. We'd times by 20 to get that. So that would be 4 times 20 would be 80. And look at that. 80 hundredths, or in other words, 8/10. So there would be 80 women for every 100 men. So your assignment is just to kind of explore some of those relationships. And again, some of this might get kind of difficult, some of the fractions or decimals, but do the best you can. Make sure you ask questions, and we'll tie this all together. So this sometimes takes a while to digest.